Okay, folks, let's get started. People might come in later, but welcome to Biochemistry 341. First thing I'm going to do is share the screen. Oh, here it is. Okay, so this is our Lalima site right here. And right now I'm in this view, which is student view. And oftentimes what I see is not exactly what you guys see. So help me out if I need it. So here's the menu list. So to get the syllabus, just click on here and then click here for syllabus and it shows up. And here's the syllabus. And so if you have any questions, please stop me, okay? So that's me. Just call me Harry. Not the best name in the world, but can't choose your parents. So the best way to contact me is through email. I might even go to the Biomed building today, I'm not sure, but email, I'm always there, okay? So this is the second semester of a 2-semester survey. So general chemistry and organic chemistry and biochemistry. So you're registered, mostly we're going to cover organic and biochemistry. So this course is designed for the allied health professionals. For many years, I did teach the chemistry major, organic chemistry, and occasionally the biochem 441, which is for majors. But you'll get a different perspective in this course. People take this course for a variety of different reasons. If you ever have any questions about are you in the right class, you can just send me an email and tell me what your major is and all that kind of stuff. So the prerequisite is really just general chemistry. So biochemistry 141 really is general chemistry, but it's in a biological context. My undergraduate degree is actually biology, where I took, a lot of chemistry and microbiology and that kind of stuff. And my PhD was in biochemistry and biophysics. So I try to give a different perspective, but really, if you take any general chemistry, you're good for this. So please use Lalima and your hawaii.edu address. Don't send me some email with Yahoo or something like that, because 2 reasons: it's not the official way to do it, and it may be blocked by the university servers. So this is an asynchronous online course. Lectures and instructional videos are on our YouTube channel. And how you find the YouTube channel is right here. So you click on that, it will take you to YouTube, and then you will see nothing. This is for the protection of students, essentially. If you click on playlists, then you'll see all the different units. So you're in 341, this is for 141, and often sometimes even for Chem 100. Let's see. Let's see. We're going to have 3 live Q&A sessions per week. They're similar to office hours. If I find that there's good questions and stuff, I may record it and upload it to the YouTube channel. But hasn't been working that way lately. So the Q&A sessions are here, always on Zoom. Zoom is always chemistry is the password. And then we also have the forums. So the forums tool on the left panel is open 24/7. You can post a question in there, and I will answer them usually pretty quickly. Sometimes other students will answer them. And sometimes it actually turns into a conversation. So it's really a beneficial thing. So if you have questions about the material, please post them in Q&A forums. I'll show you that in a minute. If you have personal questions, then email me. For the Q&A forums, you're essentially in one right now. I'm just using it as the introduction. So the text is the primary source of the course. Its chapters are provided in chapters and study guides, which is also on the left panel. Sometimes I revise the the chapters even after they're uploaded. So make sure you check often to see if you have the most current one. Honestly, I haven't been able to upgrade too many of the chapters for this course. I've been working on some other things, but I have plans, especially the second one on DNA and the one on viruses. I need to do some revisions on that. Okay, so any questions so far? Okay, so we're going to have 5 units, each with its own exam and homework. The final exam is really just a Unit 5 exam. It's not a cumulative exam. And exams are about 85% of your grade. They're meant to be 1-hour exams. So when we were doing face-to-face, they had 1 hour to do it. I would often give them an extra 10 minutes or so. But now you have 2 hours. So the exams are in a PDF. And the reason that is, this is the only class I teach where I do this, is because we have to draw so many structures and the answers are always not straightforward. So short answers are not easy to type in all the time. So we'll just do it as a PDF. So you'll get your exam from Get Your Exam here. I'll show you that in a few minutes. So complete the exam, then scan it into a PDF and then upload it into homework and exams. So I'll give you 2 days to take the exam. So as soon as you download the exam, the timer starts. Okay. And so I'm not sure if I'm going to do it 9 to 5 or whatever, because usually I have to be available in case something goes wrong with the exam or students have a problem. So in the case of an unexpected illness, you need to notify the instructor, which is me. Be prepared to present a doctor's note. If you're going to go traveling, you have an itinerary set up, then you can make arrangements with me. But what I don't want you to do is just disappear and then come back 2 weeks after your exam and say, oh, I'm ready now, because it may be too late. And homework, the homework sets are also in PDF and they're found in homework and exams. So don't worry about being able to, figure out how to get the exam up and down, because you'll be doing it at least 6 times with homework before the exam. And homework is about 15% of your grade. I make them very simple. They're teaching tools. And so, anyway, here's some more information about it. Oftentimes I have students, they try to just take a picture of their exam and upload it, and it doesn't come out well. So if you upload anything, make sure it's readable. So you can also get a program that will write on the PDF. If you have iPad or similar, some of those can do that. There's programs that are going to be able to do that for you. I've had students convert the PDF into Microsoft Word and then fill it out that way and then back to PDF again. You'll find a way. So iPhones have a scanner built into the notes, and you can do it that way too. Let's see. This is an article that will give you instructions on how to do this in case you have a problem. Okay, so questions so far? So let's just go through this over here. So we went through the syllabus. We'll come back to it. This is to get started. So this is an introduction. And so this is just to get you started quickly. So some of the stuff we covered already. When you go to get lectures and instructional video on YouTube, you got to click on the playlist before you see anything. Q&A sessions, password is always chemistry. And here's just some organizational information, what we just talked about. And then internet connection. I often have students have a problem with doing stuff online. It's almost always because of their internet. It's very rarely, if ever, because of Laulima. And so here's what I do. Where is it? I plug my modem and my Wi-Fi router into a backup battery for uninterruptible power supply. I got it for less than $200 at Best Buy. That gives you at least half an hour or 45 minutes or more to complete a task if your power goes out. Okay. If Spectrum goes out, that's a different deal. Okay. So here's where the announcements will show up. So here's the announcement that I emailed to everybody. So when I post an announcement here, I have the option of sending it to everybody in Laulima, which I always do. So you get it in your email as well as it's being posted permanently here in announcements. Here's this chapters and study guides. So for unit 1 is basically a review. So here's review of molecular structure. Now I've been teaching chemistry of all types since, for like 35, 38 years, something like that. One of the first handouts I ever made was on doing Lewis structures. And so I have maybe not a unique way of doing it, but a simplified way of doing Lewis structures. You might want to try it out. As a guy who spent many years teaching organic chemistry, what I'll tell you and what I've told all the other chemistry faculty, students don't have a problem with the organic. They have a problem with drawing Lewis structures because they never learned how. And I tried so hard to get people to spend more time on teaching this subject, but I don't get anywhere with these faculty. Anyway, here's this very simple method. And I can go through it really quickly, just right here, just using water. So here's the molecular formula. It doesn't tell you what atom is bonded to what atom. We use Lewis electron dot theory to get the structural formula. Okay. And so that's easy. I'm looking at this right here, and a couple things I can tell already. Oxygen is going to be the central atom because it's the central atom, and it's the one that can form the most number of bonds. Hydrogen will then have to come onto the outside because there's more of it, and because it can only really form one bond. But, you have to count up all the valence electrons, and here you have the completed Lewis structure. And then we use what's called electron pair repulsion theory to get the shape. Every region of electron density, which there's 4 over here, 2 of these reds are bonding, 2 of them are non-bonding, but nevertheless, there's 4. And all four of these electron-rich lobes repel each other, giving this shape, which is a tetrahedron. This is a three-dimensional shape. And then we use the difference in electronegativity to determine what kind of bonds are these right here. Okay. And the difference in electronegativity between these bonds is 1.24, putting it into the category of being a polar covalent bond. Polar covalent bonds become dipoles because the electrons are pulled from the electropositive element towards the electronegative element, leaving a partial positive charge here and a partial negative charge here, which I just put on top of the electron cloud here. So this is a dipole. And then from that, we can see that these two dipoles or electrical charges do not cancel out because they're not 180 degrees from one another, like you would see over here, but they're actually 109.5 degrees to each other. And so they do not cancel out. There's a net dipole in the water molecule. Therefore, we say the water molecule is polar, but really there's a little magnetic field here. So this becomes a magnet. And what do you know about magnets? Magnets are attracted to other magnets. So why do water molecules stick together? They're little magnets. Why does a water molecule dissolve ammonia? Because they're both magnets. Why does a water molecule not dissolve oxygen? Because oxygen is nonpolar, it's a symmetrical molecule, and it does not act like a magnet. And so you may argue, well, why does oxygen dissolve in water? Well, that's because oxygen is going hundreds, if not 1,000 miles per hour and crashes through the barrier and bounces around inside the liquid. Not really attracted to it. If you raise the temperature, you just drive it right out because the molecules are moving faster. Anyway, there's those kind of reviews right here. And so hopefully you will get a better understanding of the general chemistry needed to understand the organic chemistry and then the biochemistry. So questions so far? But really, here's the first chapter on organic chemistry. Okay. And you see a lot of it is about naming. So when it comes to organic chemistry, it's kind of organized in three types of learning. Naming the compounds, being able to draw their structures, and then knowing whether they're polar or non-polar, because that determines their biological activities oftentimes. Okay, so what's next? Lectures on YouTube. I showed you that already. Khan Academy, there's stuff in Khan Academy that will be way over your head, especially when we get to the biochemistry part. There are stuff that has seemed too simple and it changes all the time. So I don't really go there and steal any of their videos. But what I would say, I would go to Khan Academy before anything else. If you just do a Google search on things, you'll get so many wrong answers. It's just not worth it. So homework and exams is here. So we're still in your view. So here's how you see the first homework. So it's a PDF and you can just download it onto your computer by clicking here. Oftentimes it will show up. So it's very simple. Okay, the due dates are all over the place. And then,
Harry,
yes, go ahead.
I had a question on the homework. I know this class is pretty condensed. Do you provide feedback on the homework so we know if we got it right to use for studying, or is it just completion?
No, I grade the homework. I grade the homework and then I post an answer key.
Okay, awesome. Thank you.
Sure. So get exam here, you don't see the exams because they're not available yet, but if I exit the view, yeah, you can see what I have here, okay? So the forums, you're doing that right now. Oh, she meant the forums. The forums are here. So I have for syllabus and course structure for the first 6 homeworks, which is unit 1. Here's the review chapters. And here's the actual organic. And then here's a review. So this is all there. So chapter 23, for example. Let's see, no posted. Yeah. So if you post into forums, then I get notified. I get an email. And so I can go in there and answer it. You know, assuming I'm not asleep or something. And so here's the Q&A session, which you're in this one right here. Okay. Then grade book, all your grades will be here. Okay. So there's nothing posted yet here. I'll see why this is uncategorized. I have to go fix that. But here's again the due dates, right? Let's see. So here's your email. So you can email me. Actually, this is actually meant so I can email the rest. There's an email archive that keeps track of all the emails that go back and forth. That probably won't be very important to you. Let's see, let's go back to the syllabus. Okay, where are we? Okay, so for exam 5, I do extra credit. So this is the only part of the course where I do extra credit, but it applies only to your final exam score. So 1 for 5 points added to your exam, which means you could theoretically get 105% on your exam. Just write a half page explaining what useful skills that you learned from biochemistry, you know, from this course. Oftentimes I get students who've had organic chemistry and everything, but they don't know how to apply it. And then also for 10 points, you can write a 1-page research paper on any subject that you find interesting. So that means if you got an 85% on exam 5, you could raise it to 100 or even 115%. So questions about that? So grading, here's the weight right here. And is based upon this scale right here. I don't necessarily use that scale. What I normally do is I get all the exams and everything graded and everything, got your final score. I make a histogram. Then I decide where to do these cutoffs for A and a B and a C. And it's very rare anybody gets down here in this course. Almost like graduate school. If you get a C, you're failing. But the other thing I do is of your first 4 exams, I counted only half as much as the other exams. So if you do really poorly on exam 1 because you're struggling with organic chemistry still, that's okay. That exam counts only half as much as your other ones. Okay, so it's a weighted average I use. So questions so far? So I have to do student participation certification by July 10th. So that means if you've done any of the homework or whatever, I know you're a breathing student and I can just tell them so. If you haven't done anything, they may actually drop you from the course and then make you re-enroll and all this other BS stuff. So yeah, just make sure you do the homework. And July 10th is also the day to, if you want to drop the course, you won't get a W on your transcript. If you wait until the 26th, then you will get a W. After that date, I can't do anything. You have to go to the Dean of Outreach College and you have to discuss with them why you should still get able to withdraw. I just always tell students, don't put yourself in a position where you're under the auspices of somebody else. Don't give anybody power over you. Never. Okay, so I don't get this much anymore, but I used to. It's like, why do we have to know this? All those kind of questions like this. It's like, we don't need to know this to be a doctor. It's like, well, you don't know because you're not a doctor. But anyway, this is a system of knowledge similar to learning the language. And you have to know, a certain number of nouns and verbs before you can speak a language. And of course, learning the language is not simple. It takes time and it takes effort. Anyway, so here's a short synopsis of what is chemistry, what is organic chemistry, what is biochemistry. I think if you read this, you'll get a better idea of what you're studying and how you're trying to integrate and learn everything. Then I like that cartoon. I like a lot of cartoons. Then here's the lecture schedule. And so, what did I do? Yeah, here's the exams. So your first exam is next week, Tuesday and Wednesday. And it's on Unit 1, which is in black. And your second exam is here, Thursday and Friday. And this is Unit 2 in blue right here. So it goes on and so forth like that. So here's the last day to withdraw. Let's see. Let me get towards the end. It gets a little bit crazy because the last day of instruction is right here. And so essentially you're lecturing right here, and then the next day you have the final. There's no time to study. But then some people are jumping on an airplane that night and all kind of stuff. So this is the official last day of instruction when the exam 5 is supposed to be given. But I found a way to also offer it on August 12th. But then that's the final day because the grades are due the next morning. So you do have that option for the final exam. Yeah, so that's it for the syllabus. Does anybody have any questions about anything? The syllabus? What kind of things are in the chapters? The lectures? Homework? So just to summarize, you get your homework from here. You download it, put your answers, upload it here. Okay. Exams, you download here. Make it, it's a PDF. You do whatever you need to do to get it filled out and you upload it here. Okay. So anybody have any questions? You have another 25 minutes or so. See, so unit 1. So I gave you the old periodic table that I use. I use this one because I don't think they care about patent anymore. And this one has a whole lot of information on it. So if you look at it, it's got the atomic number, atomic weight, oxidation states. There's all kind of stuff over here. Here's the electron configuration. If you look at, oops, where to go? Hey, I'm back. If you look at the key right here, it tells you what everything is. Okay. So here's the backside. It tells you everything over here. So it gives you a lot of information. Whereas the new periodic tables are generally, they don't give you very much information at all, which is the exact opposite reason for a periodic table. Somewhere on my desktop, I have the latest periodic table from the American Chemical Society. Yeah, maybe I'll just upload that later. I'm going to get all confused with everything here. And then let's see. I can go back here. I went through the basic scenario over here. So then I broke it down for every step over here. Like here's step A, B, and C, and D, right? Step A is where students have a really hard time. And so first I did it for covalent compounds. That means it's all nonmetals. There's only going to be covalent bonds. Then the central atom is between the other atoms. It's going to be the least abundant atom and can form the most number of bonds. It's often also the least electronegative one. And so here's the number of bonds in a generalized sense. So you determine the central atom, put the other atoms around the central atom in a symmetrical way, and symmetry dominates because electron clouds simply repel electron clouds. Then you connect the nonmetals with lines representing covalent bonds. Do not draw a covalent bond between a metal and a nonmetal because that's going to be an ionic bond. Okay. So then the last 3 steps can prove that the bonding arrangement is possible. Okay. So you add up the total number of valence electrons. So the group number gives you the valence electrons, right? Get that from the periodic table. And then you distribute the valence electrons first into the bonds, then into the outer atoms, and then finally to the central atoms. So outer atoms should get an octet, which represents S2P6, which is noble gas electron configuration. And hydrogen gets a duet, which is 1s2, symbolizing helium electron configuration. And so if you look at the psychology of this, why did you put electrons first into the bonds? Because you drew the bonds up here. So every bond has to have at least 2 electrons in it, right? And then into the outer atoms. Well, why? Because the central atom basically decided to be the central atom, meaning that if there's ever not enough or too many, it has to suck it up and take the responsibility. its job is to make the outer atoms happy. Okay. So if the octet rule is not satisfied for the central atom, then you may be able to move non-binding electron pairs into multiple bonds, form double bonds or triple bonds only if necessary. Never just take a partial Lewis dot structure and just randomly just add a double bond, because it's probably going to be wrong. So anyway, here's some examples. So this one is very similar to water, right? So selenium is going to be the central atom. These are going to be the outer atoms. So that's the thing I try. I got to prove that. So I got to count up all the valence electrons. I have 8. So where did I put them? 2 here, 2 here. Okay, now I have 4 left over. This is happy because it's 1s2. This is happy because it's 1s2. So selenium has only 4 electrons around it, so I put the other 4 around it. Okay. So this is just like water. Its basic structure is a tetrahedral, but its real structure is that it's bent. Here's another one. And then here's another one. You can see the whole sequence is exactly the same. Okay. Then we get over here, and I'm counting up all the valence electrons. I got 12, so I put them into the bonds, right? And then I count up all of, put them into the bonds, and then what do I have left? Here's 2, 4, 6. So I have 6 more left over. These guys are already happy, right? So I put the rest onto the oxygen, and now the oxygen is happy. I got 2, 4, 6, 8 electrons around that oxygen, symbolizing S2P6. But then I check to make sure everybody's happy. This guy's got 1s2, that guy's S2P6, this guy's 1s2. What about carbon? Carbon has 6 electrons around it where it wants to have 8. So what do? I share and I make a double bond. And I don't share from oxygen because it doesn't have any excess to share with, but oxygen does. So when you take this non-binding electron pair and drop it into a bonding electron pair, does that make the oxygen lose electrons? The answer is no. It still has 2, 4, 6, 8 around it. But now carbon has 2, 4, 6, 8 electrons around it. Everybody's happy. So this is a valid Lewis structure. So then I did a similar thing for oxygen. Now you know why oxygen has a double bond. Questions so far? And what do you do with ionic compounds? There's a metal and 1 or more nonmetals. So there's going to be at least 1 ionic bond. Okay. So what you're going to do is you're going to take electrons from the metal cations according to the positive charge. Like, so sodium ion is losing an electron, right? It's going to be given to a nonmetal. So representative metals should have no dots around them. Transition metals might have some remaining electron dots. So to make it easier to understand how we do Lewis structures, we put brackets between a metal and the nonmetals to represent the ionic bond. So this right here represents the ionic bond. Okay. And then for the nonmetals, which are going to be anions, they still have to meet the octet rule. So if you look at magnesium chloride, magnesium wants to form the +2 ion. I know that because I look at the periodic table, it's in group 2, and the only oxidation state that magnesium has is the +2. Also, if magnesium on the periodic table loses 2 electrons, it now is isoelectronic to a noble gas, so it's stable. Why did magnesium form the +2 ion? Because it's stable. More stable than magnesium, the metal. And chlorine had 7 valence electrons of its own because it's in group 7 on the periodic table. But it gets that negative charge because if it gains 1 more electron, it becomes isoelectronic to a noble gas. So because magnesium is losing 2 electrons, I have to have 2 chlorines there to accept it. The number of electrons lost has to equal the number of electrons gained. Another way of looking at that is that when you do formulas for ionic compounds, this 2 comes down here and that 1 goes down there. But we don't normally do the 1. Let me go to the periodic table and review what we just did. So here's magnesium, okay? It's going to be, these are the S's, 1, 2, 3, so shell number 3, so 3s1, 3s2. But I see that 2 right there, meaning that the only thing that knows how to do is lose 2 electrons. If it loses 2 electrons, it's like sodium and then neon. And what do we know about neon? It's a noble gas and it's stable. If magnesium were to lose only 1 valence electron, then it would be like sodium, but sodium is super reactive. What about chlorine? Chlorine is right here. It's S2P5. It wants to become S2P6, like all the noble gases here, except for helium. So if it were to gain 1 electron, then it becomes isoelectronic to the noble gas and becomes more stable. So chloride is more stable than chlorine. And you look at the oxidation numbers up here. There's a plus or minus 1, and a +7, a +5, and a +2 or 3. I can't see that. Need my glasses for that. 3. So the only one that's valid for an ionic compound is going to be the -1, because that's makes it isoelectronic to a noble gas. These other numbers are right here is when chlorine acts as the central atom. When it reacts with something that is more electronegative than itself, for example, if you had fluorine. So one possible compound would be, say, chlorine 1 and fluorine 5. Fluorine 1, fluorine 3. But that's a little bit more advanced. Okay. And so why do these elements even do this? Sodium, if you have sodium metal, you throw it in water, it essentially blows up in this effort to become the sodium ion. In Organic Chemistry 273 lab, I actually used to have my students use sodium to blow up organic molecules so we could look at what structures were left. So for example, if an organic molecule had a chlorine on it, when you blow it up with sodium, you will be able to find sodium chloride. If it had a cyano group on it, you would be able to find sodium cyanide, that kind of a thing. So it's very reactive. Magnesium is not as reactive as sodium. It's, you put it in water, not much happens, but if you get it next to a flame or something, it basically goes off. Magnesium is what's used in a lot of sparklers, and it also can be explosive. Remember the sparkler bombs. Chlorine gas is extremely toxic. If you breathe in chlorine gas, you die because it basically rips molecules from your lungs, turns into hydrochloric acid, and destroys your lungs. So that'll kill you. You eat that, that could kill you. Eat that, that would definitely kill you. But sodium chloride you sprinkle on your food and makes it taste better. Put it in some water, go surfing. Okay, so let's see. That's similar. That's another example. Now here's a polyatomic ion. Okay. Sodium carbonate is called washing soda. Okay, you can go to hardware store and buy it. So it's got two sodiums. So between the sodiums and the carbonate is an ionic bond, but the bond between the nonmetal and the nonmetal is going to be a covalent bond. And the central atom of this would be the carbon. So that tells me that I need to represent the ionic bond this way and the covalent bonds this way. And then I just do the same old thing. I count up all the valence electrons. So I got 4 from the carbon, I got 18 from the oxygen, and that -2 right there, that's 2 more valence electrons that originally came from the sodium. So there's a total of 24. So I put all the valence electrons, I did that over here, and then I look for happiness. 8 electrons here, 8 here, 8 here. All the oxygens are represented as S2P6, their noble gas electron configuration, they're happy. Carbon, 2, 4, 6. Nope, that's not correct. It's not happy. So I can take 2 electrons from any of these 3 oxygens and share them. And then I can give 2, 4, 6, 8 to the central atom. Now it's happy. And now I have 3 regions of electron density around that central atom. It's going to be planar trigonal. Okay. So questions so far? Then how do we get the shape? And I don't know why it's been this way, but it took me years to be able to figure out the best presentation for all this stuff, because there's so many stupid stuff on the internet and in textbooks. There's stuff that's stupid, there's stuff that's wrong. I don't get it. Anyway, I adopted the acronym REDS for regions of electron density. And region of electron density is just a place where there's electrons. So for example, this chlorine right here has 1, 2, 3, 4 regions of electron density. The hydrogen has only 1. If you look at this oxygen over here, a double bond is this a region of electron density. So there's only 1, 2, 3. Okay. And so what are the shapes? The number of reds around a central atom. Where did I put that? I meant to emphasize that it's a central atom. So diatomic molecules have no central atom. So for example, HCl, O2, there's no central atom. So we have to add the word central atom to make sure that we're going to get the right shape. So if there's 0 reds, then it's diatomic. No bond angles. If there's 2, then it's going to be linear. The bond angle is 180. If there's 3, it's trigonal planar, 120 degrees. If there's 4, it's tetrahedral. So I have 4 regions of electron density. The bond angle between them is 109.5 degrees. That's just the geometric shape. So the first 4 right here are the ones that meet all the rules, all the bonding rules. Then if you go to what's 5 and 6, what you're going to notice is that the central atom is not meeting the octet rule anymore. So for hexahedral, I got 1, 2, 3, 4, 5 reds, 5 times 2 electrons in each bond is 10. That's not meeting the octet rule. So it's not going to be stable, but these molecules exist. Same here with octahedral. They do exist. And if you take, the chemistry major's organic chemistry courses, the 1 year of it, you will see reagents that don't meet the octet rule. And the reason for that is if you have a molecule that's an organic molecule, it's going to be, rather unreactive. So how do you make it react with something? You have to have that something be something that's very reactive. So in general, hexahedral, octahedral, those compounds are going to be able to give away atoms to another molecule. Okay. So then you get the shape when you just look at the atoms. Okay. Or essentially what we do with the shape in a traditional way is we look at what the X-ray diffraction machines tell us. And they see only the atoms. They do not see non-bonding electron pairs. So if you take water molecule and look at it in X-ray diffraction, you see that it's bent. Okay. So then diatomic just gives you diatomic shape. Linear can give you linear. If you take off an atom, then you get diatomic again. You got trigonal planar with 3 reds. Okay, if you got 3 reds and 0 non-bonding reds, then it's trigonal planar. If you take off an atom, it becomes bent. If you take off 2 atoms, then it becomes diatomic. So I did this in the chapter on the lecture, so that might help see it that way. And then we can start taking all that basic stuff and applying it to atoms that have more than one central atom. So I'm working my way towards doing organic chemistry, by the way. That's the reason why I'm doing this. So if I look at a molecule like N2O, my first thought would be that the central atoms are nitrogen and the surrounding atoms are going to be oxygen. There's more oxygens. Oxygen forms only 2, nitrogen forms 3 bonds, and there's less of them. So I would start off with this kind of structure. So here's what I did. Start off with that, count up all the valence electrons, put them into the outer atoms and the bonds, and then I go and check for happiness. Happy, 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 happy. That's by design, right? But then nitrogen and nitrogen are both not happy. So this nitrogen is electron deficient, so it makes no sense to try to take electrons from another electron deficient atom. But that nitrogen has 2 friends it is bonded with, and they both got plenty of electrons. So I could share from here or from here. Now I go to the other side. I could share from here or here. And that's how I got that structure. And in the last few minutes, we can do an example of an organic compound. This is a rather complicated one. But at this point, I would not expect you to be able to take this formula right here and get that. But in general, with organic chemistry, the carbon atoms are bonded to itself, right? So that would give me that basic structure. Then I would know that oic acid means that it's a carboxylic acid, so I would have that as a functional group. And that YN right there tells me that it's a triple bond. Okay. So I do the same thing though. I add up all the valence electrons. I put it first into the bonds and then into the outer atoms, right? And then I look for atoms that don't have enough electrons. So oxygen could use 2 more, that could use some more. One of these could use some more. And by the time I get all the valence electrons coordinated and everything, then this is the structure I get. So we'll just leave it like that. I think it's a good review. And if you never had in your general chemistry class, or if you never took organic chemistry, then you probably didn't get a very good introduction into how to do Lewis structures, but that's a concise way of doing it. So by the way, I ended up just trying to use up all the time, and I basically gave a lecture, right? I won't normally do that because this is just a Q&A session. It's like office hours. It's not, you don't go visit a professor's office hours to get a lecture, right? The lecture is already done and recorded. So any questions before we call it a day?
I don't have any, thank you.
Okay. Well, again, just to
No,
sum up,
I'm good, thank you.
yeah. So just to summarize, you know, if you have during the week or weekend or whatever, a question about something to do with the material, post it into the forums. And I will get to it within a couple hours. Okay. Anyway, thanks for coming and have a great day.
Thank you, you too.
Okay, take care, folks. Bye.
Thank you.